Hello again, my name is Rene, and this is a course of practical activities. In this lecture, we are going data manipulation in cookies, and that means we are going to the further with manipulation tools and algorithms in cookies to to support your project. So last time we cut out students population layer. We added streets network layer also, and now we have to move on with filtering. Why we have to filter and what is the filter is that we could not include all the areas where there is too few students living, but before that we have to must go on with have gravity model. So, going back to the gravity model, we have to add centroids to every polygon. So, what centroids will do is that we will decrease our problem and prepare data for the further analyze. And how we could do it, we have to find a centroid algorithm at toolbar. But first, let's open the cookies and let's open the project we are going on. So at the moment, my project name is main project. So all the layers are included over here. Next, I have to make an, I will take out some layers to see it better. Now I have to add an under the vector, go processing tools, is not over here. Our geometric tools, there is a centroids. That tool will add a centroid in the middle of the area. So input layer is clipped areas as we want to add it, and let's run it. You see, we have now full new layer, and it consists of all the areas spatial middle point, and let's see what we could do with them next. We have to export it because at the moment it is temporary. Layer export save features as. Of course, I have to add. Of course, I have to watch that format is S3 save file, and coordinate system is Estonian coordinate system. And now I have permanent layer. I want to delete the old layer because I don't need it anymore. Next, what we have to do according to huff gravity model, it says that attractiveness will decrease in distance. So we have to find distance from every centroid to every school. How to make it? So we have schools, and we want to find the distance between school and every area. Here we see a little screenshot from the distance matrix algorithm, and we have to add an input point layer as a centroids, and very important is ID field, that is student number, because we want to keep that for the further analyze. Target point layer is schools, and we don't have any school name at the moment, but we will also add some kind of information there, but we have to interpret a little bit. So going back to the and we have to find kind of matrix algorithm, and we see we have distance matrix algorithm over here. We open it, and like I said, we have to add an input point layer, centroid areas, and input unique ET field is student's number, because then we could use it further analysis. Target point layer is Pärnu schools, because it contains all the schools, and target unique is our ID. We don't change those values, so we run and close. Now we have all the distance matrices. Let's see, is it it? Yep. What we see over here is that from the input ID to the target ID, we have distance of 6,503 meters. We could also try to find it by right click on the record and zoom to filter, and also flash filter. We could take the second one and say the flash filter, and so on. So now we know from this point to this point we have 3,503 meters. We could use it for half gravity model. So we have to keep it, and let's export for that. I suggest you to add all your layers to and your project on the one folder, and make a new folder for that. Distance matrix. Okay, so we have new temporary layer, permanent layer, and we remove old layer. We don't need anymore the centroid areas. We want to now hold on a distant matrix. So next step is filtering, and we want to filter out areas where origin is less of some kind of X. What the origin ID represents us is that how many students are living on that area. So it's not very practical to make a non-motorized traffic street where from that area only comes from about 10 students or 15 students. So we have to make kind of value that under that value we don't want to see any point on the map. For that we have to use filtering, and I will toggle out clipped areas to see things better. And let's click on the distance metric, right click on it, open attribute table, let's dock it, and also we have to right click on that and use filter. You see on the input ID we have some of zeros, and we have different values over here. We have zeros, that means from this area 0 students will come or trip. It's not very useful to use those data inputs on our model. So let's make I will use 45 as the number for filtering. So filter and input ID has to be bigger or the same as 45, and let's test. Yes, it will filtering out all the areas that are under that value. When I filter inside cookies, it's also noticing by this mark over here that I'm using a filter, and I will use this labels on distance matrix, so it's easier to interpret how many students come from this or that point, because this is the input area. And next of the 4-step traffic forecasting model is trip distribution. And for this we have to construct a OD matrix, and we want to know how many students will trip from one home to particular school. For that I have a little example. Let's say we have origin of 100 students from particular area, and we want to know how much is the distance to school 1, school 2, school 3, and so on. Now we have only 3 schools, so it's easy. We have to add 3 new attributes to our attribute table, and for that we want to go to the distance matrix attribute table, and we want to add another attribute. Let's go to the cookies. We have this distance matrix, and let's open the attribute table, stock it, and open field calculator. So we could add a new field, create a new field, and we want to add a name for the field. So distance to, let's say 1. This is the school number 1. And first let's add all the values to 0, and let's hit OK. You see we created the new field, distance to the school number 1 from every area, and so on. So we have to add another distance to second school, and distance field calculator, distance to third school. Next I have to, of course, save all my work. Next is a little bit maybe complicated to understand first, but you have to read it through a few times and maybe you understand it better. We want to update existing fields now. First I initially put all those records or features values to 0, but next I want to open field calculator again. Now I want to update existing fields, and I want to update distance 1. So I have to add an expression, and this expression is when the destination is the same as whatever distance I want to add there, then I add distance. It's maybe not very well explained at the moment, but when you get you do it through, you understand it better. So first, where I found this expression, it's under the conditional case, and this is the default or template. So case when target id, so I have found it from the fields and values. Target id is the same as distance 1. Sorry, I only have to put only 1. Then I want to add a distance to there. So what will this expression make? It takes every feature target id and check, is it 1? Is it the same as 1? And when it is, it will sorry, I have to take those off. Yep. When it is 1, I add an distance value to the value of the distance 1 cell. When it is not that, it stays to 0. Let's see what it make to us. And you see, when, let's take it closer look, when target id is 1, we put distance to distance 1. So helps us to categorize different things. The same thing with the distance 2. When target ID is 2, then we want to add a distance to this feature value distance 2. And you see the third one have to be on that row. So updating existing distance 3, and from conditionals case I want to fields and values condition target ID have to be equal to 3, and I want to add an then I want to add a distance to there. So like you see, when target ID is 1, then I add a distance to distance 1. When target ID is 2, I add a distance to only to distance 2. So I have 3 more attributes for every every school, and I save my work, and also I save my project. Next, what we want to do is add all the distances from one input ID and add distance to distance 2 and distance 3. For that we have to change a little bit our table. So from input ID 90, we want to know also how much is it to the school number 2. So you can do it by hand. So you have to group those rows to that tree and add all the distances to the uppest or the first feature also. And so on. So I will skip that part. You have to do it by yourself, and see you when I have format my table. So you see I have ended up by adding all those distances from one particular home area to every school, school 1, school 2, school 3. And next I want to get rid of unnecessary records or features. So I will do that by activating them, and to make that I have to hold on the control key on the keyboard, and then I can select all unnecessary fields, and after that I will delete them because I don't need them anymore. So I'll double check my fields that is not activated. Okay, and to delete all the features I have to delete selected features, and of course I have to save the edits. And next thing is to save my project also. So what I have now is from the input ID, that means a home area, and that value inside the input ID represent the student's number. I have also distance meters to every school. I could get rid of target ID and distance by going delete field and delete target and distance. Okay, so it's look nicer. Next step is to find attractiveness. So first we have to find attractiveness for each school, and the attractiveness is based on the maximum number of the students the school could hold, and the distance, and divided by the distance score. So it's important to use this integer numbers and precision at least 6 places. I will use this maximum students number set, but you have your own defined by the project. And when I have done all those attractiveness, I have to add all the attractiveness together and make an total attractiveness. Let's see how to make it in cookies. I want to go to the cookies, and next I will open attribute table, docket, and let's open field calculator. I have to add create a new field, and it is attractiveness of first school integer, yes, and decimal number and 6 places. Now I have to know how much students could maximum be on the particular school. It is 750. Now I have to divide it by, and so I have to add distance 1 square, so distance 1 multiplied by distance 1, and it will give us attractiveness of this school for every home area. Let's see how it end up. Those are very small numbers because that's why we used so big precision. Let's make the attractiveness of the second school, and what is the maximum number? 600. Divided by, and distance 2 multiplied by distance 2, and let's add this, and the third one also. It gives us insight how much it will pull students, and the maximum number of students is 450, and fields have to be distance to 3 divided by distance to 3, and I have to change the output field type precision. So we have now, let's assume we have the first record over here. This is area over here where the students come from. We know that about 100 students will start their trip from here, and we know that how much every school will attract from this area the students. Now we have to move on, of course, save your work also, project. Now we have to add so-called market share, but before we want to know the total attractiveness for each home, and this have to be under here, attractiveness total, and real number, precision of course 6, and now let's sum up just all the attractiveness. So sorry, I made a little mistake because I already choose the first row, so I have to untoggle the only update one selected features, and update existing field attractiveness total, and let's make the expression again. So now all the fields are filled. So save edits and save my project. Next, what I want to do is to to find the market share. Market share is, in our context, how much students will go to this school. For that, I have to do the next new field. I have to toggle out only update one selected features, and students to the first school. Maybe I can be better. Students to 1. So we will use integer over here, and now I have to first divide various fields and values attractiveness of first school by the total attractiveness, and I have to multiply it by the input ID, because this is the maximum number of students that could be go to this school. Let's see, is it working or not? And you see, give us a number of 40 by taking account attractiveness of school 1 and total attractiveness, because we divide students between 3 schools. Let's take the third one also, second one, sorry. So first I have to take the attractiveness of second school, divide it by total attractiveness, and multiply it by, sorry, where is it? Input ID. Let's see. You see that I will of course save my work, but I want to show you that where is the schools, Pärnu schools. I want to visualize it by adding labels and ID. Yes. So let's add an labels also to the input layers, to the distance matrix layer. So what we see over here is that to school 1, that is over here, we are going to have 40 students from the area of here, and 39 students to the school over here. Why? Because this school number 1 is bigger and school number 2 is smaller, but school number 2 is near to the school number 1, so it's not very big difference for that. So try to make students to the third school by yourself, and I have already made it. So next step will be filtering first out students to the first school that is higher than 100 students that will go to the school number 1. We know that this is school number 1, and from here students sold, and here students sold go to school number 1. Next we should try to understand does all those features inside distance matrix layer are really correct, and for that let's open attribute table and let's stock it, and for better visualization let's add labels or distance matrix and clipped areas. We want to see a student's number or the input ID, both of them. So as you see, there is double records, because when we go on the distance matrix, you see this is the multi-point. That means it connects two points together as the one feature. When I click on, when I try to click on the select features by area, click on it and click one point, you see here is a first point, but when I try to click on all those points over here, all other points also selected. So I have to divide all the points and make them a single point. For that I have algorithm or multi-part to single parts. I have to use this algorithm, and for the distance matrix layer, and let's run. Let's see what we have now. We have single parts, and when I want to see attribute table of the single parts, I see there is many records. It's because we divided them, and let's try to understand how many points are there. More than I need. Yeah, it should be. Let's delete all them because I don't need them. There is one more. I have to save. And why I have one more, I don't know at the moment. Let's take a look over here. Now I have only a single parts as they are distant matrix now. I could close this dialog, and now you see I have only the single points showing me. So I have to, of course, toggle editing out. I have to delete the distant matrix, old distance matrix layer. Then I could export the single parts layer, save features as, and I can overwrite old distance matrix, but before, of course, I have to delete it from the layer panel. Save. Okay, and overwrite file. So I have only single parts. Old single parts layer I could delete, and now I can join two. I have to first, of course, save my project, but I could now bring those points layer values to the area. That means on the clipped areas layer. How to make it? You have to join attributes by location, because we know that point location is center of the area. I could do that. Clipped areas are the base layer, and I want to join it by the distance matrix, and I want to join fields as students to number 1 school, students to number 2, students to number 3. Okay, and let's run it, and let's see what we have now. We have now joined layer, and let's take a closer look. Single labels, but do we have now students to number 1? Yes, we have. Are they really correct? Also, we have to check from the distance matrix, and let's add the distance matrix labels also. But let's change the color so we can distinct them. Yes, so distance matrix is in blue, and joined layer is on the. So we want to understand this students to school number 1 the same. Yes, they are. So I will say now the records are correct, the features are correct. So I could export the joined layer because it contains now all the features from the distance matrix layer, and also it is now area based, so it's very important for us. So save features as, and we want it to be named as a students to school. I have to overwrite it because I already tried it out. So okay, new students to school, and I could also delete joined layer because it's temporary. Now I have the final layer of where I could let's toggle in the Pärnu school also, and students to school, let's add an labels, single labels, and let's try out students to school number 1. We see how many where and how many students will attend to school number 1 based on the huff gravity model. Let's see students to the school number 2. Okay, so and students to school number 3. You see, those are the values. I hope it makes any sense to you, because those are very important part of the project. Now we could go on before let's save our work, move on to the next part, but for this lecture it is enough. So thank you for your attention and see you next week. But this is enough for this lecture. We'll see you on the next lecture. Thank you for attention.